Welcome, everyone. Thanks so much for joining us at our Electrify Your Home webinar. We're so pleased you could join us today for about an hour to talk with our friend and expert, Sarah Grant, about electrifying your home. We hope it's useful for you, and we're excited to have you. Before we begin, I wanted to acknowledge that SolarShare's projects are located on the traditional and unceded territories of many Anishinaabe First Nations, including the Ottawa, Algonquin, Ojibwe, Mississaugas of the Credit, and Saugeen First Nations. We're grateful for the opportunity to live, work, and gather together on this land. The other thing I wanted to do before we begin was to launch a poll to just get a sense of the folks who are on the call. And the Zoom session is telling me I've logged in from another device, so I'll see if I can fix that problem. Sorry, 1 second. See if I can fix it. Okay, we'll deal with that later. Sorry, everybody. Let's see if I can make this work. The wonders of Zoom. Okay, let's see. Did I do it? No, I haven't. Okay, well, never mind. Sorry, everybody. My apologies. Marina, if my colleague Marina can maybe help me with that, I'd appreciate it. Okay, so let's talk about electrifying our homes. But first, I wanted to tell you, if you don't know about SolarShare, SolarShare is a not-for-profit cooperative. We were founded in 2010 here in Ontario. And what we do is we own, operate, and finance solar projects in the province. So we own 51 projects all across the province, and we finance them with what we call solar bonds, which are community bonds that any resident of Ontario can purchase. So over time, we've raised more than $80 million and returned more than $12 million in interest to our members to support those 15 megawatts of solar in the province. I encourage you to check out our website. There's a QR code there if you like, solarbonds.ca. At that website, you can see our projects and you can see their performance in real time. You can sign up for our newsletter, which I hope you already have done, or read our blog. And you can learn more about and purchase solar bonds. Right now, we're not on sale. We sold out in April. However, we plan on being back on sale in June. The other thing I want to say, please use the chat function to ask questions. During this time, I'm going to try and gather those questions and ask them during the webinar. And if we don't get time for them during the webinar, then we will have some time at the end of the webinar to try and answer as many questions as we can. So why would we want to electrify our homes? Probably you're curious or you know about this already if you're at this webinar. But really, I'd say it's like 4 different things for me. It comes down to it's more efficient, which is really great. Electricity is a wonderful type of energy, and it can be used for all sorts of things, and it's a very efficient way of energy, efficient source of energy or use of energy. So that means that it becomes more cost effective to electrify because we're using that energy more efficiently. And also, we're able to reduce greenhouse gas emissions, because we don't need to use fossil fuels to heat or power our homes, but also because of the efficiency of that. And also because in Ontario, in particular, we have a relatively low greenhouse gas emissions intensity, although that is projected to increase significantly over the next decade or so as this government puts in more natural gas fired generation. The other thing I wanted to mention, we've learned a lot more about this, and you may have heard about it. It improves air quality to electrify your home. Burning natural gas or methane gas in your home does have health consequences. It's important to turn on your vent if you are using your gas stove. So it's better just not to have combustion inside your home, and electrification helps to avoid those indoor air quality issues. We're not going to talk a lot about solar today, although that's obviously a component of potentially electrifying your home. And we love solar here at SolarShare. But we did do a webinar for solar for your home last November. So I encourage you, it is available for you to take a look. This is being recorded as well, so you can check it out later. But I encourage you to go check out that Solar for Your Home webinar, where we speak with our operations and maintenance manager, Bob Ross. And then we also had a webinar on ending gas subsidies. The government unfortunately just passed a bill 2 days ago that overturned the Ontario Energy Board decision to end those subsidies for new gas connections to homes. So I encourage you to take a look at that. So enough about all that. Let's talk about what we're going to talk about today. We're going to talk about the incentives around electrifying your home. There's been a lot of changes you might have heard in the media. Sarah's going to help us understand those. We're going to talk about home energy and emissions. So how does our home use energy, and where do the emissions come from when we're using energy in our homes? The importance of efficiency, home efficiency, and the envelope of our home, the walls and the insulation and the air sealing for our homes. Then we're going to get into heating and cooling. So your HVAC system, hot water, how can we electrify those components? What about other appliances that don't use electricity, like your stove, maybe your dryer, fireplaces? And throughout, as I mentioned, we're going to try and answer those questions as they come up. And then if we aren't able to get to all of them, then we'll try our best to answer them at the end of the webinar. So I'm so pleased that we have with us today Sarah Grant, our expert on home electrification. I had the pleasure of meeting Sarah when we were both working with Engineers Without Borders quite a while ago now. And it was really, she's a really great person, and she went on to found and grow a bunch of other organizations that all have to do with energy and the environment. So I'm really pleased to have her here today. Sarah is the co-founder. Her latest venture is Goldfinch Energy. It's a purpose-driven and women-led energy services firm based here in Toronto. Sarah is a certified energy manager, or certified energy advisor rather, and has completed hundreds and hundreds of home assessments. So we're very fortunate to have Sarah with us today to talk about electrifying your home. So without further ado, Sarah, I'd love you to take it over, please.
Sounds good. Thank you so much, Chris. Yes. It's nice to retell our history with Engineers Without Borders. And yeah, this is, I guess, my latest venture, but it is something that I hope to continue with for the next decade plus. 4 years ago, when the pandemic hit, a friend of mine approached me and said, look, like, when my gas furnace broke, I asked about heat pumps. She was working with the Pembina Institute and an advocacy organization that some of you may be aware of. And so she knew a little bit about heat pumps, but didn't know enough to advocate for herself and for her home. And so she was laughed at and talked out of one, and ended up with a massive 100,000 BTU furnace, big furnace, and stuck on fossil fuels. And so Goldfinch Energy was started to help people electrify their homes. And we're a team of energy advisors, and who then also can provide energy audits, help people with rebates. But we like to do more than just rebate processing, although I recognize that's an important part of it. But we do aim to help people make good intentional decisions with their homes, whether it is something with your heating, or it is a new homeowner who's just trying to get a handle on what's going on with their home. How should they plan for repairs, or you're planning a big renovation? How can you make the most of it and make it green? And so I'm here, happy to answer any and all questions that you have, whether they're high level, specific, whatever. So as Chris said, feel free to interject as I go along. So let's talk about the incentives. So yeah, lots has happened in the last little while. Up until February 5th, there were 2 programs running. The federal government was implementing what's called the Federal Greener Homes Program, and Enbridge was actually mandated by the Ontario Energy Board to implement that program in Ontario, and they were topping up the rebates by about 30%. So you could get up to $10,000 worth of rebates. And if you did get an energy audit on or before February 5th, 2024, depending on how you fit into the time frame, you're either in for the Greener Homes program, or if you got your audit in 2023, then you also happen to get in time to qualify for that combined program called HER Plus. Unfortunately, if you haven't yet had an energy audit, then you won't be able to access those programs. I guess just to close the loop, in case you are on this call and you did get an audit, but you haven't yet claimed your rebates. Right now, they're saying that homeowners have it up until February 2027 to complete the work and get a post retrofit audit and submit your rebate claims. I don't know if that date will stay, to be honest. There's been lots of changes with the timeframes and the rules and whatnot. So I just am recommending to people, if you are counting on those rebates, try your best to get things done, in a timely manner and get that audit scheduled and close things off as soon as you can. So if you haven't yet got an energy audit, I recommend waiting. Right now, at the federal level, they have made a commitment towards some affordability programs. So there will be likely rebates for items like heat pumps. It'll be an income-based program. So I don't know exactly what they the income bracket at, but low and middle income is where they've said they would like to support and make in order to make our housing more affordable. The program, to be honest, if I'm speaking candidly, may not be as generous as the Greener Homes program. There's only, I think, about $1 billion in the budget. Meanwhile, with the Greener Homes program, which was ran for multiple years and reached hundreds of thousands of homeowners, had about $4 billion in the budget. So, and it's scheduled to launch in 2025. So may not be worth planning your life around in any sort of way. Anything can happen. Not exactly sure. With regards to Enbridge, they historically have had a mandate, again, by the Ontario Energy Board, to use a portion of ratepayer funds to help people reduce their gas consumption. So some people always ask, why is Enbridge implementing these programs? But that is why. And they get then sort of compensated for this accordingly. So they have historically had rebate programs, and then along the line paired up with the federal program, and now are going to be relaunching a program that probably will look very similar to their previous programs. So typically their programs have been maybe around $5,000. Don't quote me on that, but around that. And typically they haven't included heat pumps, but again, the Ontario Energy Board has some clout to some extent sometimes on them, and have asked them to include rebates for heat pumps and probably some smaller amounts for insulation, windows, getting your house more airtight, that kind of thing. And it'll probably look very similar to most of the programs you're familiar with, where to qualify, you have to start as an Enbridge customer and likely have to heat with gas at the beginning. Again, don't quote me. These aren't the rules. I'm just speculating based on what I've seen from previous programs. But it will require an energy audit to get in the program, and then to claim your rebates. Once you've done all the work, you will have to submit receipts and get a post retrofit energy audit. Hopefully this program will be announced soon. Enbridge has worked out the details and proposed it to the Ontario Energy Board. I've heard as early as June 1st, although I don't know exactly if that's going to happen, but sometime soon there will be a program that hopefully will help at the very least. If you're in a circumstance where you have to replace a broken air conditioner and you're thinking about electrifying your home, a heat pump is a great option, and I'll get into that later. I know that the rebates specifically for heat pumps have been designed to basically make the cost difference between a new AC and a heat pump moot. So it'll take that cost difference out. There are also a couple of loans available federally. That Greener Homes program that was providing grants, they also have a loan that's still available. You can borrow up to $40,000 and it's zero interest. You have 10 years to pay it back. It isn't for everyone, because you do basically have to pay for the work up front. So say if you're going to install a heat pump or solar panels or do some insulation, you basically pay for it, get the initial energy audit, get the work done, pay for it, and then get a post retrofit audit. And at that time, you get the money back. So you basically, in the time between you pay for it and the time that your Greener Homes loan is closed, you need to be paying for that. You've paid for the heat pump or whatever. Maybe you borrowed from another source. So It's something though, if you're going to be borrowing from another source, rather pay that off and pay off a zero interest loan and take your time to do that. The City of Toronto has a low interest loan program. The terms change based on how much you borrow, but called their Home Energy Loan Program, or HELP. And along with that loan program, it is better than, say, out a home equity line of credit in terms of the terms, in terms of the rates rather. And along with it comes some incentives. They have a $2,500 heat pump incentive and a $1,000 solar PV incentive. They also have a $10,000 incentive if you do a lot of work and really reduce your home's energy consumption by 80% or more. And if you're thinking, wow, $10,000 sounds great, just to sort of set expectations, typically the homeowners that I've worked with that have qualified end up doing, like, I was lucky enough and able to do this, but we had to renovate our basement because we needed an extra bathroom. And so we added a bunch of insulation. We got solar panels on our roof. We redid the flat roof and added insulation beforehand. We electrified our house. And so all of those kind of 4 items got us to a point where we reduced our home's energy consumption by more than 80%. So, but if you are planning to do a reno to that scope, it's something worth looking at.
And I believe other municipalities have incentives as well. Are you aware of those, Sarah?
Yeah, I'm not as knowledgeable because I am based in Toronto and I've mostly helped folks in Toronto. I know Guelph has a really good one because I've been invited to help folks there. And out in Durham, I believe there is one as well, but I'm not sure. I'm seeing Markham, Richmond Hill. I'm not sure if there's anything specifically in those areas, to be honest. But I know the funds for these loan programs come from CMHC, the Canadian Municipal Housing Corporation. And anyway, so you could hopefully maybe do a quick Google search and look up your city and see if there's anything. Sometimes they're called the PACE program as well. So that might help with your searching.
Great.
I'll try and do some research after this so I can better answer that question next time.
It's disparate, I believe, across different municipalities. Yeah.
Yeah. But it's anyway, definitely, like, just as a side note, as much as I encourage everyone to make intentional improvements to their home each and every time, you have a broken furnace, air conditioner, hot water, you need to replace your stove, you need to do your flat roof. It's always a good idea to think about what you can do to make your house more energy efficient, to electrify it. But these incentives do certainly help. They help those who may not have the means if something is a little bit more expensive. And when the previous program was in place, they did help speed up our rate of electrification, which we to address our climate crisis, we do need to do. Yes, the PEAL program. Thank you, David. Okay, so home energy and emissions. This is just sort of like a big picture, kind of where your home is at. So as far as if you just take a look at energy consumption in your home, a typical home, about 60% of it, the energy consumption will come from space heating and cooling. Most of that will be space heating. And that's mostly because if you think about in the winter, if it's cold, say it's -10, -20 on a really cold day, and you're trying to heat to 20 degrees or so, that's a 10 or so degree difference. In the summer, when it's hot out, it might be like 30 degrees out, and we might set our thermostat to say 24 something. That's 6-degree difference. So the energy consumed to make up that, say, 30 degrees versus 6 degrees is significantly larger. And it's our climate too. So because our homes often are a little bit older, and because of that temperature difference, we're using a lot more energy to heat our home than we are to heat our hot water, to use all the other appliances that Chris mentioned, and to light up our home. This may not be true for your home if you're in a new home that was built recently and isn't exceptionally large. Maybe there were better than building code levels of insulation and air leakage work done. Then these numbers might look a little bit different. The space heating and cooling could be a bit lower, and then the hot water might be the largest source. But this is just sort of a typical home, especially if you're in Toronto, typical older Toronto home. And as far as sort of emissions go, most of our homes are heated with fossil fuels. And so because space heating is the number one source of energy consumption, it also becomes in our house the number one source of emissions. Typical home, depending on the size, like that home in the picture, that's actually my home with my son in front of our sign. So we're in a little East York semi, and our house before we switched to a heat pump was emitting about 5 tons of greenhouse gas emissions per year, which is kind of similar to driving a gas car around 15, 20,000 kilometers per year, average size sedan or whatever. But, a larger home, obviously, larger emissions. There are a few homes in Toronto that are heated with electric baseboards. So the emissions aren't significant, but baseboard heating is not a very efficient form of heating. So they're gonna see really high bills, and their numbers for energy consumed for space heating will be even higher than they would be for a gas appliance. I see Chris has put electrical panel replacement. So I know often if you're thinking about electrifying your home, that's a big thing on people's minds. And I'm not necessarily going to be able to help you walk away today saying I do or I don't need to upgrade to 200 amps. I do find often contractors are still a little bit more conservative, and they will often say you have to when that may not be the case. And I just encourage you to ask a few more people and get a little bit more advice, because that can, for some people, that's price. People that I've worked with out of fully electrifying their home, they were told they had to. And, so they opted then for a heat pump with the gas furnace as a backup, because that wouldn't draw as much electricity. And so that system, helped them avoid a $4,000 or $5,000 cost to upgrade to 200 amps. There is, if you're really curious about how much electricity your house currently uses, you can go onto your Toronto Hydro account and look at your historical consumption. And I recommend you look at start with month by month and pick a really bad month. Maybe it's with air conditioning, that's okay. You click on it and you go day by day, you click on that and it'll show you your hourly consumption. And if you take that hourly consumption, it's in kilowatts, you times it by 1,000, divided by 240. I can type this in the chat after. That'll tell you how many amps you drew on that day when maybe you had your air conditioner chugging and maybe your dryer, although most people don't. But anyway, maybe. And, or if you've already started electrifying your house and you're wondering if you're getting close, that will give you an idea. You could even turn on everything and then go check a little bit later. That way you'll know, rather than having a contractor come and talk you into spending $4,000 or $5,000 extra. I have also worked with a few people who have opted for smart panels. So rather than upgrading to 200 amps, there are panels that have smart switches, and you can even then kind of control things from your phone. So if it's a really cold day and you've electrified your home and you've got a heat pump and maybe you needed that auxiliary electric heating, which I'll talk about in a little bit, but both of those things will draw electricity, and maybe you're also trying to do a few extra things. It might send you an alert. It depends on how you set it up. It might sort of prioritize some things over another. So that can save you a little bit as well. The other thing that I'll say is my house, the one that you see in the background, up until we got an electric vehicle, we were on fully electric and 100 amps, and we didn't have any problems. So we had a heat pump, an induction stove, a simple electric tank. We also have solar panels with the inverter that draws a little bit of electricity. And there was never any issues there. And I've worked in many homes where they've stayed on 100 amps and have been fine. The worst case sort of scenario is if you end up drawing more than 100 amps, your main breaker will flip. So you will have to go down to the basement in the dark and flip it back and sort of realize, okay, what was running that caused that to happen? And that, of course, can get really annoying, especially if it's in the middle of the night on a cold day. But that would be your big tell as well. So
and Sarah, have you had any?
Yeah.
Sorry, have you had any challenges with utilities in terms of upgrading, like extreme costs or challenges with that, and maybe system challenges?
Yeah, I know that if your service comes above the ground, like you can probably see in the background of that picture, you see all those power lines above, then in that case, no, the costs are going to be around $4,000 or $5,000 typically, with an electrician who will get the permit and and work with Toronto Hydro to upgrade. It'll be a delay. I think there's usually about a 6 or 8 week delay before it can happen. But that's been sort of the smoother stuff. I know that if you have a below ground service, the costs can be greater, and it can require a little bit more time, a little bit more back and forth. Frankly, because I've mostly worked in Toronto, or most of it is above ground, I only have one person in Richmond Hill and one person in a newer build downtown who have had below grade costs. That in one case she just decided, okay, I my house is a 1980s build anyway, so I may not need to upgrade to 200 amps. So I worked with her and did her energy audit, and which included calculating very carefully, like what's the size of heating system required in her house, and would a heat pump on its own or an electric backup, like what's the best system for your house? What will that draw? What are the other appliances you plan to electrify? And we work together with to calculate it, and then work with an HVAC contractor as well. And so she was able to stay on 100 amps. In the downtown Toronto one, they did upgrade to 200 amps with below grade. And initially, I think they had been quoted really high number, and then they found someone else who was able to do it for a much more affordable
Okay,
cost.
great. Thank you.
So yeah. And I see David's asking about just like being able to understand when the resistance. Yeah, so yeah, you can install something on your panel to understand when the resistance heat is coming on, because basically that's going to be a separate breaker on your panel. And so yeah, you may be able to then take note of when it's on, when you need it as well.
Great.
All right. So efficiency and envelope. So we're mostly going to be talking about electrifying your home, which, primarily is your appliances. It's your heating, your hot water, and the other appliances that may be burning fossil fuels to do the job. But I just wanted to talk a little bit about what's called your building envelope. Your building envelope is the technical term that refers to sort of the part of your house that is the barrier between the inside and the outside. So that's, if you look at, like, say the picture on the slide right now, that's the door that's currently open, and the window above the door, it's the walls. That's actually a shared wall that I'm along, so it's not a shared wall. That's not the barrier, because usually your neighbor is keeping their house at whatever 20 plus degrees or something like that. Your ceiling, your attic, if you have one, that kind of thing. And typically, when it comes to electrifying a home, it can be a little bit more complicated if you're dealing with a home that's fairly large and uninsulated, sort of, maybe it's 100 years old, it hasn't had much done, it's drafty, it leaks like a sieve. So this red thing that you see in the picture is a airtightness test that an energy advisor will do as part of an energy audit, that will tell you how drafty or not your house is, and can even help you find some of the larger sources of drafts. And so an older home that may be really, really drafty, what that means when it comes to electrifying and installing a heat pump in particular is, although heat pumps are amazing and they are climate fighting machines, because our electricity grid is fairly clean, and because they are very efficient, nothing is as efficient as a heat pump in terms of generating heat and using electricity. The only thing that's better is just not needing to use as much heat. So but heat pumps don't come in as large capacity as fossil fuel appliances like a gas furnace. And so sometimes the largest heat pump that would kind of be suitable for your home and for the ductwork may need a really large source of backup heating. And so if you haven't done the work, you're going to need a big one. If you have, you may not need electric backup or gas backup, or may need it really minimally. So there is kind of this interplay between how much you've done on your building envelope and the size of heating appliance required. The other benefit is when it comes to, this stuff is, mechanical appliances, they're going to break every 20 or so years. Ideally, if you do something really well, if you insulate your walls really well, that's something where that can last for decades and decades, ideally. Hopefully, until someone decides, hopefully not to knock a house down, but it does last a lot longer if done well. And generally, the cost of energy, gas and electricity is increasing. So if you kind of look at it in like a very long-term perspective, it can make sense as far as cost too. And I would say like the biggest reason I find people do this is for comfort though. So and this is what drove us to do this is our main floor was often so cold. There was one spot in our living room that I just found I didn't enjoy sitting there. And it wasn't until I got into this work that I realized, whoa, like the way that the front of our house was designed, there was a lot of air leakage. There was this weird little jut out exposed floor. And although it was actually quite insulated, it was very, very leaky. And so we did some work to make it more comfortable. And of course, then had the side benefit of reducing the size of heating equipment required, reducing our energy bills, and making our house more efficient. Um, the other thing I want to say is that, I think that with our houses, sometimes it can feel really daunting, especially if you are a new homeowner, if this is your first time owning a home and you buy what's new to you, but maybe 100 years old, maybe with this kind of myriad of renovations that have been undertaken in the home, not by you. It may be quite daunting to try and think about like, how can I make my house more energy efficient? And one of the best ways to do the work is to incorporate it into any existing work. So for us, honestly, we had an unfinished basement, and with 3 kids and a pretty tiny, like 900 square foot main and second floor house. Instead of doing an addition, we decided to make the most of the space that we were already heating, but we're underutilizing because it wasn't efficient. We had one bathroom and just kind of wanted another one for a family of 5. And so we did a basement reno and used that as an opportunity to, of course, do what we could to make both the slab and the walls a lot better insulated, and also reduce air leakage, which I want to say often I find people when they're planning a reno or thinking about their house think about insulation, which is good, but it's only half of the equation. So air leakage often especially in old Toronto homes is often the number one source of heat loss. Like usually about 50 or 60% of heat loss comes from air leakage. And so anytime you're doing any work, whether it's a basement reno or replacing your flat roof or replacing your windows or maybe a big gut or something like that, having a plan to address air leakage is as important as adding insulation. And I won't get into too much of the details, but it can be tricky to reduce air leakage. But generally, you want to think about like adding insulation is kind of like the sweater for your house. Reducing air leakage, what you want to do is add the equivalent of a windbreaker for your house. And so if you have the opportunity to add what's called an air barrier, that's like the windbreaker. So we did that to our walls in the basement, or you do that to a flat roof from the outside on the sheathing, or to the inside of your walls if you're going to be renovating. Even having the air barrier, if you're replacing your windows, and a window installer just puts new windows in, and they usually use like spray foam and just kind of like quickly foam around where the window sits in like the 100-year-old rough opening. I've often gone back to homes and done air tightness tests where people have just replaced the windows and found that the house was like sometimes a little leakier, sometimes about the same. It's unfortunately not as often to find it more airtight. So window installation as well is this huge opportunity. And I find very, very few contractors think about adding an air barrier around the rough stud opening that your windows would sit in. Probably
Great.
sharing enough that there are a lot more questions than anything right now. So I don't know, Chris, if I should pause or what you would prefer.
Well, I think we have about 25 minutes. I'm conscious of the time, and I do want to get to the actual equipment as well. So
Okay,
why don't we
let's do
move
it.
on? There are some questions, and
Sure.
I'll jump in where I think we have some that you can answer.
Okay, so the meat of this, like electrifying our homes, the largest source of emissions is our heating. And so heat pumps, they are, if you are not familiar with them, and probably most of you on this call are, but Just at a high level, they are amazing magical black boxes that are able to pump heat from the outside and bring it inside in the winter. It may seem like impossible, but they do work. If you think about how your fridge or your freezer works, or even your air conditioner works, they are not making heat, they are moving it as well. So your air conditioner is pumping heat from inside your house outside. Even though on outside it's warmer than it is inside, they're able to do it. Your fridge and your freezer, the same thing. All of this is basically, if you want to get into sort of the chemistry, it's anytime you change the state of something, in this case, a refrigerant, it either lets off energy in the form of heat, or it it's colder and then it sort of attracts energy in the form of heat. So that's in a nutshell how heat pumps work. And we have this technology in our homes already. And heat pumps for space heating have been around for many decades. Why they have become a lot more popular recently is in the last 10 or so years, the technology's improved so that some heat pumps probably would be referred to as cold climate heat pumps can work up to minus 30 degrees Celsius. So they're still able in that outdoor minus 30 degrees Celsius, able to bring in enough warmth to keep our homes warm in the winter. So we've got a few different types of heat pumps. So I've kind of been describing an air source heat pump where it's grabbing warmth from the outdoor air, and the picture there is an air source heat pump, and it may bring in that air and it could circulate it in your ductwork, and then you've got forced air style. So you'd replace your gas furnace and air conditioner with an air source heat pump, or maybe you have cast iron radiators or in-floor heating that's heated through a hydronic source of heating, and then there are air to water heat pumps. These are not yet as common, and unfortunately, not as many contractors are familiar with them, but they are there. They are possible. Sometimes only recommended if you have done enough work on your building envelope, just because the temperature of the water won't be as hot as what, say, your boiler would have gotten the water. But it is happening in old Toronto homes. Ground source heat pumps are probably what most people, I think, initially think about when we say heat pumps, because they have been around for a lot longer. And so that involves running tubes either horizontally or vertically in the ground and extracting heat from the ground and transferring it inside, either through forced air or radiators or what have you. They are quite costly in urban centers, just because then you're running like vertical loops down, and the costs are ballparky around twice that of an air source or an air to water heat pump. But if you're in the country and you're heating with propane, which is quite costly, I've worked with a number of homeowners who have had ground source heat pumps installed and been quite happy. So in all cases, no matter what type of heat pump, they can provide both heating and cooling. And because they're not making heat, they're moving it, the efficiency is measured a little bit differently. So in the case of an air source heat pump, that might replace your gas furnace and air conditioner. It's powered by electricity, but able to produce sort of 3 times the amount of heat typically than the electricity. So the efficiency might be up to 300%. As it gets colder outside, the efficiency of a cold climate heat pump typically goes down to about 200%, which, compared to a gas appliance where you're never going to get 100%, you might on a high efficiency furnace get like 95, 97%. Baseboard heaters are 100%. 1 unit of electricity generates 1 unit of heat. Okay, backup sources of heating. So as I mentioned before, heat pumps are amazing because they are very efficient. They run on our grid, which is fairly clean. And there are other amazing benefits. They're often quieter. People find that they do a better job of evening out the temperature differences across floors because they tend to run longer. The one limitation is their capacity. So sometimes, depending on the size of your home and really like the heat loss of your home, you may need a form of backup heating. And in the case when it's a hybrid system, if you're not aiming to electrify fully, you would have a heat pump, and then at some point the thermostat will notice that the heat pump doesn't have the capacity and it'll switch over to a gas furnace. If you want to electrify fully, which I really encourage, then in that case, the heat pump is still going to run all winter long, because remember, it works up to minus 30. So it'll continue to provide heat. It's just that at some point, the heat loss in your home may be greater than what that heat pump can provide. So the thermostat will take note of that, and it'll ask for an auxiliary source of heating, which is electric, to come on and give a boost. So in this case, the costs to run a heat pump, as long as that auxiliary is not going to be running like all winter at the same time as the heat pump, as long as that heat pump can do most of your heating requirement, basically, and the auxiliary might be needed when it's really cold, then it's quite an affordable way to heat your home. Most of the homeowners that I've worked with who have that system where it's a heat pump with an auxiliary are finding they're saving a little bit each month. Nothing like significant, not anything where it's worth calculating the ROI. Maybe it's like $10 a month in most cases, sometimes 14. I've heard someone say 8. So a little bit each month, but all that to say that they're very cost effective. Even if you hear the idea that there's electric baseboard, it's giving a boost. The heat pump's still doing the work, and heat pumps are 2 to 3 times more efficient than gas or baseboards.
And I heard, Sarah, I heard through a colleague that they were electrifying their home, and they're in the city of Toronto, and they were asking their contractor about it, and they said, "Oh, you must have a backup system." And my colleague said, "Okay, show me where it says that in the bylaws," and they couldn't. So there, as to my knowledge, there's no requirement for backup. You don't have to have a gas backup or anything. Is that true?
That is absolutely true. And so if you don't have an HVAC permit, it's sometimes smoother. But if you have an HVAC permit, sometimes these bylaw officers may get a little bit fiddly and want you to have the electric auxiliary source, which can be fought. But when it comes to sizing heat pumps, sometimes you don't necessarily want to size your heat pump to do 100% of your heating requirement anyway. It's often a bit better for the heat pump and more efficient to kind of size it slightly lower so that it might do most of it up until say -10 or -15, and then you have this smaller auxiliary for when it gets really cold. But this is, so there's nothing in the bylaw that requires the backup. By building code, if your heat pump can provide your heating load, which in Toronto the design temperature is like up to -18, if your heat loss in your house can be fully covered by the heat pump, then you don't need any source of backup or auxiliary or what have you.
Great. Thank you.
Okay, just a few more things about heat pumps, some considerations. I did kind of talk about the sizing and backup, so maybe I won't go into that. The thermostat. So when it comes to an all-electric system, you will get slightly better performance if you go with a thermostat that's made by the company that makes the heat pump. Even though it may seem like on the thermostat side, you're just setting the temperature to 21 or whatever you want to set it to, and maybe dropping it by a degree or two overnight. There's a lot of kind of communication that goes on behind the scenes between the outdoor and the indoor heat pumps, and the thermostat is kind of the command center, the quarterback of that communication. So you will get slightly more efficiency by going with that. Unfortunately, I think that's the one area where there's a lot of engineers who have designed heat pumps and they're amazing in how they work, but I wish there were more kind of artists and whatnot who have taken a look at thermostats to make them a little bit more user-friendly and interesting. But most often with the heat pump, you just kind of want to set it and forget it. You don't want to get fancy like you might with the gas appliance. So if you once you get a heat pump, set the thermostat settings and kind of leave it for the most point, you'll be happier that way anyway. Some pictures of some outdoor heat pumps. So on the top left there is a larger sized heat pump which has 2 fans on it. So it is tall. It's about 6 feet on a snow stand. And the physical size depends on the capacity that you may need in your home. And then on the bottom left is a slightly smaller heat pump that could be wall mounted. If you have a double brick home, you could wall mount yours. Ours is wall mounted, which doesn't cause us any issues with noise. Some framed houses, I don't recommend it. And double fan ones, I don't recommend it either. The vibrations are too much that you'll get the noise coming through your house. But if you're in a small house and you don't need a large heat pump, that's a good option. I should have grabbed pictures, but I have a few homeowners who have done some nice lattice work around them as well to try and sort of blend them more into their garden as well, if if that's of interest. Um, Ductwork capacity. So just to kind of put it in your mind that it's important to work with an HVAC contractor who understands how to properly size the heat pump, and not just for the heating requirement in your home, but heat pumps, the temperature of the air from a heat pump isn't as hot as a gas appliance. So um, as a result, it needs to push more air. And so if your ductwork is a little bit small, that's maybe why the contractor might be saying you need a slightly smaller heat pump than what they would like to put in. But you know, getting that tested and checked is important. I talked about location. Ductless unit. So the cool thing about heat pumps is you don't just have to do, like, if you have forced air, but say you have a third story that you may not be able to afford to renovate. And so it's always a little bit too cold in the winter and too hot in the summer. There are heat pumps where you would only pay for one outdoor heat pump, and then you have an indoor unit that connects to your ductwork. And then you could also have that same outdoor heat pump connect to a ductless heat pump, which will just go on the wall on the third floor and get you that sort of more direct source of heating and cooling. So they're kind of cool in that way that you can kind of mix and match, which in some cases in our old homes, if you're not able to sort of undergo a large renovation and do a lot of work to reduce your air leakage and add insulation and improve your ductwork, then that may be an option as well. Brands. So on this photo, actually all those heat pumps, even though there are two different stickers, they're all made by the same company. And so they're all made by Medea, which is the blue sticker there. They're one of the largest heat pump manufacturers in the world. The other is called Gree. And a lot of North American companies like Lennox and Carrier and Bosch even has gotten it. They're not making their own heat pumps. They're putting their names on these heat pumps. And I'm not saying it as like a bad thing. I'm saying it because I've seen some companies like Bosch leveraging kind of their name. They have a great name in the dishwasher industry, but they're kind of leveraging it to upsell a heat pump, which just, I think it's important to know what you're getting. There are a few companies, the most well-known one and most popular, has the largest market share, is Mitsubishi Electric. So that they make their own stuff, as does Daikin and Fujitsu. There's just some costs that if you are potentially gonna, like, you have a newer gas furnace and you're just gonna replace the heat pump or the air conditioner with the heat pump, you'll be spending about $5,000 to $8,000. If you're able to go fully electric and replacing both your air conditioner and furnace, then the costs are closer to $14,000 to $20,000. The range is partially size, but mostly brand. So the companies that make their own stuff, they charge more than the companies where they're putting their name on someone else's.
Got it.
All right, we can keep going.
Sure.
Okay, water heating. So the largest source of emissions is space heating. The second largest is typically heating your water. And, so most folks may have a gas on demand or a gas tank. And switching that to electric is going to cut your emissions as well. There are kind of two systems. I saw some chatter about on demand, so I can speak to that. But there are two systems out there that I think are most worth looking at, the most going to be kind of most popular for most of you. So the heat pump technology exists in hot water. So that's the unit on the left there. What it's doing is grabbing warmth from, say, your basement, which may be where your hot water tank is, and transferring it to the water itself. Their efficiency is like 400%. So amazing as far as cost goes, as far as efficiency goes. They may not be for everyone because they're grabbing warmth from the basement. And so if you have other issues that may cause your basement to be cold unnecessarily and you're not able to address those, this may not be the right option, because then it's just going to make your basement even more uncomfortable. They also need to be either in a room that's about 10 by 10 feet, or if that room has like a door with a vent on it, then it'll be able to just basically in a space where it can grab enough warmth. So good if you have the space and your basement is kind of doesn't have any issues with discomfort. But not always for everyone. The sort of alternative, which is what I opted for because our basement is small and just sort of wanted to go with something that might be a little simpler, is we installed what's called a drain water heat recovery system, that kind of weird coil thing. We put that so that when we're showering, instead of all that warmth from the shower going down the drain, that coil there is grabbing that warmth from the water. The water doesn't exchange. It's fresh city water that's cold, starts cold, but then can increase its temperature. It can grab about 50 to 70% of the heat that's going down the drain and transfers that into the tank before then the electric tank does its work. So this sort of system is fairly cost effective as well. And then if you are on time of use, you can install it with a timer so that the water only reheats overnight when electricity is at its cheapest. You might want to size up your tank just so that you have a little bit more in the day in case, but that's something you can sort of think about and talk about with whoever you work with to get this done. But yeah, so basically a heat pump hot water tank or an electric tank, maybe with the drain water, maybe with the timer. I've had like 2 people now do on-demand electric tanks, but they're like not very efficient because electricity running through anything trying to heat up water really quickly is not an efficient form of heating. But they're nice because they save space, but they're not very common because they're quite costly, and they would definitely require you to upgrade to 200 amps. Like the one I saw in someone's house had 260 amp breakers. So they're power hogs.
Great. How about other appliances?
Okay, yeah. So probably the next most common one in most homes would be our cooking. So gas stoves used to be very common, chefs were promoting them, but I think things have changed. And a lot of chefs are now promoting induction stoves. They are amazing for many reasons. From an air quality issue, as Chris already mentioned, gas stoves have been linked to higher rates of respiratory issues. And so if you do have a gas stove and you can't yet afford to change it out, please use your exhaust fan, not only when you're doing the cooktop, but when you're cooking in the oven too. That's the bigger culprit. So switching out that gas stove for an induction when you can is really smart for your health, but also they're amazing. We just got one, and I've got little kids, and I feel a lot more comfortable with them cooking because now just the way that they work, the cooktop doesn't get hot, just the pan itself. And so it's a lot safer if they like drop a paper like tea towel or whatever, it's not going to catch on fire on it. Um, you may need to buy new pots and pans. You can check if you have magnetic pots and pans by put a magnet on the bottom and see if it sticks to it. So that's something to consider. And you'll need someone who's got a gas license to disconnect the gas if you've got a gas stove, so that you can have get rid of the gas stove. So there's a little bit of work there that you might need to think about. But yeah, they're great. The actual cooking, like the stove part is electric, but the top is the induction aspect of it. I see lots of positive comments for induction stoves.
Yeah, and thanks. Casper says that the copper pots with steel bases, you could get those. So you just need some sort of magnetic material in your cookware to make that work.
Yes, true. Not as many people, but there are still some folks out there who have gas dryers. So worth mentioning if you are trying to electrify your home rather than going for a standard electric dryer, heat pump technology also exists in dryers. It's everywhere. And we also have a heat pump dryer in our house. And I got it in part because I wanted to make our house as airtight as possible, so it doesn't exhaust in the same way that an electric dryer would. And so it's one less hole in our house. And they what's nice about them in the winter anyway is they put out this nice warm, slightly humid air as they operate, which is great. In the summer, I don't notice it as a negative, but I do notice it as a positive in the winter. They do take longer, so for us, it just means we're we happy to not necessarily think that we need to do 5 loads of laundry in one night, just sort of spread out our laundry. But typically sort of about 50% longer to dry a load of laundry. But
Is
a
there
good
any
option if
difference
you've
in the
got a gas
heat?
dryer.
Is there any difference in the amount of heat or amount of energy that a air source heat pump dryer would use compared to a conventional dryer? It's the
Definitely
same amount of
less, but
energy. Less? Yeah.
yeah,
Okay.
yeah, definitely less. I haven't dove into the numbers enough to know exactly what that would be like.
Okay.
Yeah,
Cool.
it's a good question. Fireplaces. So okay, there. Michelle Hewitt says it's about 1/3 the energy. Thanks, Michelle. Um, for fireplaces, there are some folks who have gas fireplaces, and I would say if you want to electrify everything for environmental reasons, for health reasons, there are 2 good options. And I've worked with people where this is kind of like the last source of like gas consumption in their house, and they just get frustrated looking at their monthly Enbridge bill and seeing that they're paying Enbridge like $40 a month just to have access to the gas. So cancel that gas account, get rid of that gas fireplace. And a couple of ideas that folks I've seen do. One is just convert that gas fireplace back to a wood fireplace. So in this case, you're getting then something that if there's a power outage, you can still heat your home, because no matter what, if you've got forced air anyway, if you've got a heat pump or a gas furnace, if there's a power outage, you're going to be without heat. So wood fireplace may be an option, as long as you're not burning a lot of trees to do this. But anyway, that's another conversation. But otherwise, there are electric fireplaces, and the photos I've shown they're vapor based, so they run on electricity, but they put out like this vapor. One green architect that I am working with has is likely to install one of these. So, and they have excellent design taste. So I anticipate this to become a very popular item. I've not once yet seen one in someone's house though, so can't speak to it personally. I've worked with people who also just decided to sort of, they disconnected the gas, but they kept the fireplace because they just liked the look of it too, and sort of just the ambiance even when it's not operating. So lots of options there to think about, and sort of personal choice on where you go with that one.
Amazing. Thank you so much, Sarah. This is really great. All the information you provided. There's a couple of reasons. I know we're at the end of our time here. We do have a couple of resources here. One of our members, Heather McDermott, is working with the Building Decarbonization Alliance to put together a guide for Canada, similar to what Rewiring America has done with Electrify Everything Home Guide. You can see a picture of it there on the left-hand side of your screen. So look for that at the end of the summer this year, which will be really helpful. The Ontario Clean Air Alliance, Friends of Solar Share, also have heat pump calculator and some other great resources and studies that they've done. So do check those out. We are at the end of the time. Hopefully we answered most of your questions. I did see, thanks to everyone who was communicating in the chat as well, in helping to answer those questions. There's a lot of really keen and knowledgeable people on this call, so we really appreciate that. Thank you for your help answering the questions. And Marina, are we able to launch our poll? Can we try and do that before we leave, and just see how?
Yeah, you should be able to do that.
Okay.
On your
Let's see.
end, Chris.
Okay, thanks, Marina. Let me do our poll. No, it's still not letting me. That's too bad. So sorry, we weren't able to do our poll, so we'll have to forego that. But once again, thanks so much to Sarah Grant of Goldfinch Energy for taking the time to be with us here today. And thanks to all of you for spending an hour learning about electrifying your home. We hope to come back with more webinars that'll be of interest to all of you in the future. And thank you, Marina. You did that.
I was able to, yeah.
Okay, amazing. Marina, thank you for saving us. So if you don't mind, we'd love your feedback. How did you like this webinar? And if you want to give us some thoughts on topics we can cover in future, we would love to do more of these and have more great speakers like Sarah Grant come and help us and our members understand various topics around energy, solar, electricity, things that are in our sphere. Anything you want to say before we're done, Sarah?
No, I was just scrolling through the chat. Lots of good chatter, lots of very informed folks out there, which is so great. Like it's been so inspiring to see over the last few years, like more and more people. And I'm sure there's like a selection bias of those who opted to come to this today. But the more we can all like inform ourselves and practice what we preach and then help inform and educate others so that maybe that next gas furnace that breaks might get replaced with an all electric heat pump is so good.
Amazing. Thanks so much, Sarah. Thanks all of you for participating and contributing in the chat and being here with us. We really appreciate it. Have a great long weekend, and we look forward to seeing you at our next webinar. Take care.
Awesome. Thanks, Chris. This was fun.
Thanks, everyone. Bye. Thanks, everyone.
Bye.
Take care.